Yo ho ho! Here we are with chapter 8, lesson number 2, completing the square. Now if I asked you to find out the turning point of a quadratic, you could do it different ways. One way is to go through the steps that we did in the last lesson, but another way to do it is to use what's known as completing the square. This is something that we have come across before. You were introduced to it last year. Now if you remember, whenever you complete the square, you have to half the coefficient of the x term. You have to then subtract what's known as the correction number, which I shall do in the examples. And for each one that you came across last year, the coefficient of x squared was 1, and you need the coefficient of x squared to be 1 before you complete the square. However, with higher, you will not always get that, so you then have to work your way around that. Once you get an answer, it should look something like y equals a bracket x plus b all squared plus c. And if you have that, what you do is you take whatever's in the bracket and you change the sign, so positive to negative, negative to positive, so b would become negative b in the turning point, and the number that's on the end, the plus or the minus, just stays as it is. So your plus c would remain as plus c, and that would give you the turning point. Let's do a few examples then. I've got quite a few of these going from easy to hard, and for each one we want to express the function in the form a bracket x plus p all squared plus q by completing the square. We're then wanting to state the maximum or the minimum turning point. So let's start off with y equals x squared plus 6x. So the first thing we do is we half the coefficient of x. So when we write it, we'd have in brackets x plus 3 all squared, because we're halving the 6. Imagine if you multiplied that out. If you had x plus 3 all squared, well, multiplying that out would give you x squared plus 6x plus 9. Really, the question though, we've got the x squared, which is fine, it says that here. We've got the 6x, which again is fine, but we've also, if we multiply out x plus 3, bracket x plus 3, we've also got plus 9. We don't want that plus 9, which is why for the correction number, we always square that number there and then subtract it. So it would end up as take away 9, because we don't want it. We're getting rid of that. Because we have it in that form, we've got 1 bracket x plus 3 all squared minus 9. We can then state the turning point. X squared is a positive, the coefficient is 1. And if it's 1, it means the graph's going to be a smiley face. And if you had your smiley face, it means the turning point would be the lowest point. So you'd have a minimum turning point here. So the minimum turning point, in brackets, we've got a plus 3. So the x coordinate will be a negative 3. And the minus 9 will stay as minus 9. So the turning point, you'd have negative 3, negative 9. Example number 2. This time, same question, but we've got y equals x squared minus 10x. First thing you do, half the coefficient of x. So in brackets we'd have x minus 5 all squared. If you square negative 5, you get 25, and you're always taking that away. And that's us, we've got our answer. Again, x squared is a positive, so you know that your graph is going to be like a smiley face, so you'd have a minimum turning point. And the minimum turning point would be, in brackets we've got a negative 5, which would then become plus 5, and on the end we've got a negative 25, which will stay as it is. So that is your minimum turning point. Again, I've put this over here for all the questions. I'm just showing you if you have x minus 5 all squared and you go and you multiply it out, you'll have just what you've got here, but you've got that extra plus 25. So again, you're just taking it away. So I've put this over here for all the examples. Example number 3, again write it in this form by completing the square, state the maximum or minimum turning point. So with this one, again, you want to start off the exact same way. You're wanting to half the coefficient of x. So doing that, we've got a 4, so that becomes 2, so we've got x plus 2 all squared. The correction number this time, square the 2, you get 4, you're always taking that away, so that's where the negative 4 comes on. And we've got a plus 7 as well, so plus 7, if you've got a number in the end, it just stays as it is. However, what you'll notice is that you can simplify that. You've got a negative 4 and a plus 7. Well, negative 4 add 7 is 3. So you can just simplify that to get x plus 2 all squared plus 3. Again, I've just got this bit over at this side. So if you did multiply x plus 2 all squared, you'd get that extra 4, which is why you take that away. Leave the 7 as it is, and that'll become a plus 3. Minimum or maximum turning point? Well, the coefficient of x squared is 1, which is a positive number, so you'd have a minimum turning point. And the minimum turning point would be -2, 3. Again, you're taking the number in here and changing the sign and keeping that number just as it is. Example number 4, x squared plus 3x. So for this one, half the coefficient of x. So if you halve 3, you get 1.5. Square that and take it away. 1.5 squared is 2.25. That's us. We can't do anything else with it. So you'd state the maximum or minimum turning point. Again, it's 1x squared, so it's a minimum turning point, and you'd have -1.5, and this number just stays as it is with -2.25. Example number 5, y equals x squared minus x minus 3. Again, half the coefficient of x, so instead of -1, we'd have -0.5 or -1/2. You can either work through it with decimals or with fractions, it's entirely up to you. And if you square -0.5, so -1/2 squared, you'll end up with a quarter, so you want to subtract a quarter, or 0.25. Keep that -3 just as it is. From there, you can then simplify -0.25, take away 3, that gives you -3.25. Maximum or minimum turning point? It's 1x squared. If it's a 1, it's a smiley face, meaning it'll be the lowest point. So it's a minimum turning point. This time, we've got -0.5, so that'll go to 0.5. And you've got a -3.25 in the end, so it'll stay as -3.25. Example 6. Y equals 4x squared plus 8x. This time, it's slightly different because we're needing a coefficient of x squared to be 1. But you'll notice you've got a 4x squared, so if we've got that, we can't just leap into halving that coefficient and so on. It doesn't work. What you need to do is you need to try and alter this so you get just a coefficient of x squared. And what you may notice is that you've got 4 here, you've got 8 here, you've got a common factor there of 4x. But you don't want to take out x, okay? Just take out the 4. So if you take out the 4 as a common factor, then you'd have 4 brackets, and then you'd have x squared plus 2x. And putting in the square brackets, because you know when you complete the square, later on you're going to have just the normal brackets. So this just makes it easy to tell the difference. So now in the brackets we've got x squared plus 2x. So we can complete the square for that bit. So half the coefficient there, and you get a 1, which means then you'd have x plus 1 all squared. So keep the 4 just as it is. Complete the square just for this part, so we've got x plus 1 all squared. Remember the correction number, 1 squared is 1, you take it away. Again, close brackets. And then from there, you can multiply out those square brackets. So 4 times the x plus 1 all squared will give you 4 brackets, x plus 1 all squared. And then 4 times -1 gives you -4. Again, we've got it in that form. So you can state what the maximum or minimum turning point would be. Again, it's a minimum turning point, and the value, well, again, you just take this number that's in the brackets and change the sign, so that'll go to -1, and the number in the end is -4, so it'll stay as -4. This number at the front does not influence the turning point. Really, if you graphed it, it would only alter the steepness of your quadratic with graphing it. It doesn't change the turning point, so you just do that the exact same way. Example 7. Y equals 3x squared plus 18x plus 5. Again, we don't have x squared, the x squared coefficient to be 1, but we need it to be 1. So you could take out 3 as a common factor here because you've got 3 and you've got 18. Oh, it doesn't really work for 5. You know what? Let's leave it then. Don't take it out for 5. Just take the coefficient, the common factor of 3 out for the first 2 terms. So doing that, you'd have 3, and then again introduce square brackets, 3 times the x squared, and then 3 times 6x. That'll give you the 18x. Put the square brackets there because we're not taking the common factor out of this number in the end, so just leave plus 5 as plus 5. Again, looking at the bit that's just in these square brackets, well, we can now complete the square for that. So leave the 3 just as it is, leave the plus 5 just as it is, and you're only wanting to take this part and complete the square. So doing that, you'd have half the coefficient of x, which is 3. So you'd have x plus 3 all squared. Square that 3, you get 9, so you're taking 9 away. And again, you're leaving the 3, you're leaving the plus 5. Once you've done that, well, you can't do anything else with it apart from just multiply out your square brackets. So multiplying it out, you've got 3 times the x plus 3 all squared. You've got 3 times negative 9, which becomes negative 27. That gets rid of your square brackets, and then we've got this plus 5 in the end. From there, simplify it. You've got negative 27 add 5, which is negative 22. Again, you're just wanting to state is that a maximum or minimum turning point. You've got a coefficient of 3, it's a positive number, so it's a smiley face, meaning it will be the lowest point, so it's a minimum turning point. The minimum turning point this time, Sammy, what would you have? Brilliant, well done, Sammy. You'd have negative 3, negative 22. Again, you're just taking this number that's in the brackets, changing the sign, and keeping that number as it is. Example 8, y equals x squared plus 8x minus 3. Y equals 2x squared plus 8x minus 3. Again, you don't have a coefficient of x squared to be 1, but you need that, so you need to take out 2 as a common factor. You can do it with the next term as well, but you can't do it with the 3. I suppose you could, but then you go to decimals or fractions, so just leave the minus 3 as it is. So take out the 2 as a common factor of the first 2 terms, so 2 times x squared plus 4x, put in the square brackets, and then leave minus 3. And then from there, again, you can complete the square just for this middle part. So leave the 2 just as it is, leave the minus 3 just as it is, leave your square brackets, and if you complete the square, you'll end up with just this bit in here that I'm underlining. So you'd have x plus 2 all squared, and then 2 squared is 4, so you're taking that away. Multiply out your big square brackets, gives you 2 bracket x plus 2 all squared, minus 8, and then leave minus 3, and then negative 8 take away 3, gives you negative 11. You cannot do anything else with that, so you can then state your maximum or minimum turning point. From there, because you've got 2 in the brackets, it goes to negative 2, and the negative 11 will stay as negative 11. So that gives you your turning point. Woo! Let's try another one. Example number 9. Y equals 5x squared plus 35x plus 50. You can do this 2 different ways. One way you could do it is you could think, well, I can take out 5 as a common factor for every single term. So you can do that and then have 5 brackets, x squared add 7x plus 10, and then you're just going back to completing the square the way you normally would. I'm going to do one more example though with just taking it out of the first 2 terms because it still works even if you don't take it out of that last number, even if you can. So taking it out there, you've got 5 brackets, x squared plus 7x. If you close the bracket and leave plus 50, you're still going to get the same answer. It still works. So again, you're just dealing with this part in the square brackets. So complete the square for that. So leave the 5 as it is. Leave the plus 50 as it is. Half 7, you get 3.5. Square that, you will get 12.25. And then you've got nothing else to do apart from multiply out your big square brackets. Doing that, you will have 5 times the x plus 3.5 all squared. You'd have 5 times negative 12.25. And then you'd have that plus 50 just on the end. From there, with the negative 61.25 and the plus 50, you can simplify that. That's your bottom line. That's it in this form. So you can state the maximum or the minimum turning point. Maximum or minimum, Adam, what would it be? Well done, Adam. It is still a minimum. So from there, take that number and change the sign, so negative 3.5. Take that number and leave it as it is. So that will be your minimum turning point. Let's try another one. Example number 10. So example 10, you've got y equals 4x minus x squared. This time, we've got a negative for the x squared. Well, our first thought with that is because it's a negative for the x squared, it means our quadratic, the parabola, will be a sad face, meaning it will no longer be a minimum turning point. That will be the highest point on the graph, so it will be a maximum turning point. Also, we need to think, right, well, how do we deal with that? Because we've got that negative. Well, what you can do is you could take out negative 1 as a common factor. If you take out the negative 1, it'll leave you with an x squared inside brackets. So let's do that. First of all, rewrite it. So I've got a negative x squared and I've got a plus 4x. and then take out negative 1 as a common factor. So take out negative 1, I've got negative 1 times the x squared gives me negative x squared, and negative 1 times what gives me positive 4x? Well, it's negative 1 times negative 4x. Two negatives will make the positive. From there, you can then complete the square for this bit in the brackets. So we've got negative 1 times, and then half that coefficient of x, so we've got x minus 2 all squared. 2 squared is 4, so we take that away. There's nothing on the end, so we're ignoring that, and we can now multiply out our brackets again. So negative 1 times the x minus 2 all squared gives us this. Negative 1 times negative 4 gives us 4, and that's really our answer. Instead of writing negative 1 though, we could just write it as negative x minus 2 all squared, and then plus 4. You can write that a different way as well. You could put it as 4 take away x minus 2 in brackets all squared. Either way, you can then state your maximum or minimum turning point. Again, x squared is a negative, so it's going to be a maximum turning point. So your maximum turning point this time will be, Olivia? Well done, you got it. It's going to be 2, 4. Perfect. Example 11. Y equals 3 minus 8x minus x squared. Again, we've got a negative in front of the x squared. So you probably want to take out the negative as a common factor. So rewriting this first of all, well, we've got our negative x squared, we've got our negative 8x, and we've got our plus 3. Take out the negative as a common factor will give us negative 1 brackets, and then we've got x squared, that'll then become plus 8x, and that'll become negative 3 on the end. From there, we can then look at the bit in the square brackets, and we can complete the square because we've got it just the way we want it. Half the coefficient of x, so we would have 4. 4 squared is 16, so we're taking that away, and negative 3 will stay as it is. And with the negative 1 in the square brackets, you're just keeping them as they are. Inside the brackets here, we've got negative 16 take away 3. Well, we know that's negative 19, so let's do that. And again, you can just multiply out these brackets. So negative 1 times the x plus 4 all squared, and negative 1 times negative 19 will give us a 19. Again, you don't need to write the 1 just at the front. From there, maximum or minimum turning point, because x squared is a negative, it's going to be a sad face, so that turning point will be the highest point on the graph. So it's a maximum turning point of, take this number in the brackets and change the sign, it's negative 4. This number in the end stays as it is, 19, and that is what you would get. Example number 12, y equals x minus x squared. Again, with our x squared, we've got a negative at the front. So we want to take out the negative as a common factor. Writing it back to front, first of all, will give us y equals negative x squared plus x. Take out the negative as a common factor. We'd have negative 1 brackets. Then it gives us x squared minus x, because if you multiplied it out, you'd have negative x squared, and then negative x times negative 1 will give us a plus x. So that is what we'd have. And then you can complete the square for this bit in brackets. Keep the negative 1 as it is, keep the square brackets, half the coefficient of x, so half 1 you get a half, or 0.25. If you square a half, you would end up with a quarter, or 0.25. And again, you can multiply out the square brackets now. So we've got negative, in brackets, x minus 0.5 all squared, and then plus 0.25, because the negative 1 times negative 0.25 will give us the positive. Maximum or minimum turning point? Woo! You got it. It's going to be a maximum turning point here, and it's going to be at, take that number and change the sign, keep that number as it is, and that is your maximum turning point. Example number 13. For this one, we've got y equals 7 minus 8x minus 2x squared. Again, our x squared is a negative in front of it, and there's also a number in front of it. So let's deal with that. First of all, just write it back to front, put that x squared term at the front. So we've got negative 2x squared, we've still got our negative 8x, and we've got our plus 7. From here, we want an x squared. We don't want a negative 2x squared, so let's take out negative 2 as a common factor. We can also do that with this next term as well. So let's do that. We've got negative 2 times, and then we'd have x squared plus 4x. Put in the square brackets because we're finished with taking out common factors and leave the plus 7 just as it is. From there, take the bit that's in the brackets and complete the square. So the rest of it, just leave it as it is. Leave the negative 2, leave the plus 7, and if you complete the square here, we'd have x plus 2 all squared, and then take away 4. From there, multiply out the big square bracket, so negative 2 times the x plus 2 all squared. Negative 2 times negative 4 is plus 8, and plus 7 stays as it is. After that, Andrew, well done, you're right, simplify. If you do 8 add 7, you obviously get 15. So we'd have y equals negative 2 brackets, x plus 2 all squared, plus 15. Maximum or minimum turning point? Well, the coefficient in the question for x squared is a negative for the x squared, meaning then you'll have a sad face, so it'll be the maximum turning point. It'll be the highest point in the graph, and it will be, see if you can do it yourself. Woo! Did you get it right? Yeah. Last one, example 14, y equals 5 plus 3x minus 6x squared. So for this one, again, our x squared term, there's a negative in front of it and a number in front of it. Writing it back to front, I've got negative 6x squared, leave the plus 3x, leave the plus 5, and from there, take out negative 6 as a common factor. Doing that though, you can't really do that with 3 to get a nice easy number, but you could do it to go into a decimal or a fraction, so you have to do that. So doing that, we've got negative 6 brackets, bring in the square brackets. That'll give us x squared, which is what we want, and if you do 3 divided by 6, it gives us negative 1/2 for this number in here. We'll put the square brackets and leave the plus 5 just as it is. From there, you've got this bit in brackets with our x squared, so complete the square there. Doing that, negative 6 stays, plus 5 stays, and if you half a half, you will end up with a quarter. You could, again, as I said, work through this with fractions rather than decimals. If it's a non-calculator paper, you're sometimes best leaving it as fractions. So half that, we will end up with a quarter. If you square a quarter, you will end up with 1/16. So we're taking away a 16th. You can then multiply out the big square brackets, so multiply by the negative 6, gives us negative 6 brackets, x minus 0.25 all squared. That will become plus 0.375, and then the plus 5 will stay as it is. We've got this part in the end, which we can then simplify to get our answer, so it is in this form. After that, x squared up here, it was a negative for the coefficient, so we would have a sad face. It's the highest point, it's the maximum. I'm sure you know it by now after 14 examples. But from there, what would the maximum turning point be? Well, take that number and change the sign and leave the other number as it is. So that will be your maximum turning point. I did put in quite a few examples here. There are 14, so if there's any you're not sure about at all, go back and practice it. It is a big part of the course, so there are quite a few exercises. If you look at the Maths in Action Higher, page 30, exercise 1A and 1B, it's just plenty of practice with this. Complete the square for this one, complete the square for this one, and then in the Heinemann book, you've got some more of the worded questions looking at the turning points and so on. Give these questions a shot. Let me know if you need a hand. Good luck.